Translations. Translations of various shapes and designs occur all over in everyday life. So here we have bricks that are layered, and this brick is a translation or can be translated down to this brick, over to this brick, and so on. Similarly, wrapping paper also contains translations of the design. Wallpaper or the painting design of a room also shows translations of the same design. So what is a translation? Well, a translation is a slide that moves a figure to a different position, either going left, right, up, or down, and it can also be a combination of any of those directions. And it doesn't change the size or shape of the figure, nor does it flip it or turn it. It just takes it and slides to the new one. You can use an arrow to show the direction and distance of a movement. The graph shown below is a translation. The pre-image is triangle ABC, and its image is triangle A prime, B prime, C prime. Each point in the pre-image was moved 7 units to the right to create the image. And we can count this. 1, 2, 3, 4, 5, 6, 7. Notice I went from A to A prime. If I do the same with B to B prime, 1, 2, 3, 4, 5, 6, 7, I'm counting the same number of units each time. And again, from C to C prime, we have to go 1, 2, 3, 4, 5, 6, 7. So all of these points and vertices are being moved to the right 7 units. To complete a translation, we move each point of the pre-image and label the new point in our image. So in our example, we need to move the figure to the left 2 units and up 5 units. After we do that, what are going to be the coordinates of the pre-image and image? And then, are the line segments in the pre-image and image the same length? In other words, was the size of the figure preserved or kept the same? Well, let's start by moving the figure first. So we have our original quadrilateral here, A, B, C, D. And we're asked to move it to the left 2 units. Okay, 1, 2, and then up 5 units. 1, 2, 3, 4, 5. Notice we did fall directly on the diagram that was showing before. And then what are the coordinates of the pre-image and image? Okay, let's actually look at these. So for our pre-image, point A has the coordinates 1, 2, 3, -1, so 3, -1. Point B has the coordinates 1, 2, 3, 4, 5, 6, 7, 8, 8, -1. Point C is at 7, -3, and point D is at 2, -4. And now what are the coordinates at the image? So our point A prime is at 1, 4. B prime is at 1, 2, 3, 4, 5, 6. 6, 1, 2, 3, 4. 6, 4. C is at 1, 2, 3, 4, 5, 2. And D prime is at 0, 1. Okay, so we took care of that question. Now let's look at this bottom question. Are the line segments in the pre-image and image the same length? Well, yes, they are. And we can also prove that by re-dragging this back to the original. These are the same. And then if we go back to the image, these are the same. So the side lengths and angles are all preserved or kept the same. So the answer to this question is yes. And right here, this slide shows the solutions to this question, that we did indeed move this figure to the left 2 spaces and up 5, and we have these new coordinates when compared to these originals. And yes, both the pre-image and image are congruent figures. Translate pre-image triangle ABC, 2 units left and 6 down. What are the coordinates of the pre-image and image? And then, are the line segments in the pre-image and image the same length? In other words, was the size of the figure preserved? Well, let's start by doing the translation of triangle ABC. So if we translate it to the left 2 units, 1, 2, and down 6, 1, 2, 3, 4, 5, 6, our new point, A prime, will be right here. And its coordinates are 1, 2, 3, 4, -4, comma 1. All right, let's do the same with point B. We're going to go to the left 2 units and down 6. 1, 2, 1, 2, 3, 4, 5, 6. So this is going to be point B prime, and its coordinates are 1, 2, 3, 4, 5, -5. And we're going down 1, 2, 3, 4, 5. So -5, -5. And then for C prime, we start at C and we go left 2, 1, 2, and down 6. 1, 2, 3, 4, 5, 6. So here's where C prime is going to be. And its coordinates are -1, 2, 3, 4, 5, 6, 7, 8. So -8, -1, 2, 3, -3. And if we connect these, we will get our triangle A prime, B prime, C prime. And we can also label our original coordinates. For point A, we were at -2, 1, 2, 3, 4, 5, 6, 7. Point B, we're at -3, 1. And then the original point C is -1, 2, 3, 4, 5, 6. 1, 2, 3. So -6, 3. And then, are the line segments of the pre-image and image the same length? Yes, they are. Was the size of the figure preserved or keeping it the same? Yes. The pre-image and image are indeed congruent. So here's the solution for our last example. It shows how triangle ABC is translated to the left 2 and down 6 to get our image triangle A prime, B prime, C prime. And then the line segments of the pre-image and image do remain the same. So all of these line segments are congruent to one another, respectfully, and the angle measures also remained the same. Translate pre-image ABCD to the right 4 units and down 1 unit. And then what are the coordinates of the pre-image and image? Are the line segments in the pre-image and image the same length? In other words, was the size of the figure preserved? Well, let's start by writing out the coordinates of our pre-image. So point A is at -1, 2, 3, 4, 5. 1, 2, 3, 4. So we're at -5, 4. Point B is at -1, 2. Point C is at -1, 2, 3, 4. So -4, -2. And point D is at negative 1, 2, 3, 4, 5, 6, comma 1. Okay, and then we are translating this pre-image 4 units to the right and down 1 unit. So let's do that with all of them. So let's start with A. We're going to go 4 right, 1, 2, 3, 4, and down 1. So this will be point A prime, and its coordinates are negative 1, 3. Now let's look at B, which is right here, and we're going to the 4 units to the right, 1, 2, 3, 4, and down 1 unit. So this is where B prime will be, and its coordinates are 3, 1. Now let's look at C. We're going 1, 2, 3, 4, and down 1. So we are at 0, negative 3 for C prime. And then point D, we're going 1, 2, 3, 4, down 1. So D prime is here, and its coordinates are negative 2, 0. And then if we connect to these, we do get quadrilateral A prime, B prime, C prime. I want to redo this one. Okay. And then are the line segments of the pre-image and image the same length? Well, yes, they are. To get from A to D, we went down 3 units and to the left 1. Well, the same thing happened over here. And the same thing occurs with all of these. So from D to C, I'm going down 1, 2, 3, and over 2. And from D prime to C prime, I went down 3 and over 2. So it does have the same shape. So the side lengths and angles were all preserved when translating this figure. And here again is the solution. We show the coordinates of A prime, B prime, C prime, D prime after the translation to the right 4 units and down 1 unit. And we can see even more clearly on this slide how the side lengths and angle measures are fully preserved, making both the pre-image and image congruent. Now let's try to translate quadrilateral ABCD to the left 5 units and up 3 units. And we'll begin by writing in the coordinates of our pre-image. So point A is at 3, 2. Point B is at 1, 2, 3, 4, 5, 6, 7, 7, 1. Point C is at 4, 0. And point D is at 2, negative 2. And now we're going to translate this quadrilateral to the left 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So here's where A prime is going to be. And A prime is at the point negative 2, 1, 2, 3, 4, 5, 5. Now let's do the same with point D. Left 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So D prime is at negative 3, 1. Now let's look at C. Again, we're going to go left 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So C prime is at negative 1, 3. And then point B, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. So B prime is at 2, 4. And if we connect all these dots with straight lines, we can see that the line segments of the pre-image and image are the same length, and the figure's size has been preserved. And we know that because all of the segments and angles that are showing here are indeed congruent to the original. And here we can see more clearly that our pre-image and image shape are indeed the same. And we also have both the X and Y coordinates for both in here. And because the side lengths and angle measures are the same from both the original to the new figure, the figure has indeed been preserved, or the pre-image and image are congruent to one another. A rule can be written to describe translations that occur in the coordinate plane. Look at the following rules and coordinates to see if you can find a pattern. So if we look at our first one, it went 2 units to the left and it went 5 units up. So it went from 3 to 1, 8 to 6, 7 to 5, 2 to 0. Notice the x-coordinate went down by 2 units. So left might mean subtraction with the x-coordinates. Let's see if that happened also when we went 5 units left. I went from 3 to -2, 7 to 2, 4 to -1, 2 to -3. Oh yeah, I am subtracting 5 units. See, left 2, so -2 to -4, -3 to -5, -6 to -8. I'm subtracting 2 from the x-coordinate to get the new one. Now this one's going to the right 4. So if the left decreases the x-coordinate value by a certain number, then right should increase it. So let's see if that happens. -5 to -1. Okay, yeah, I added 4. -1 to 3. Oh, I added 4. -4 to 0. I'm adding 4. -6 to -2. I'm adding 4 to get my new x-coordinate. And now let's look at the up and down directions to see what happens with the y-coordinates. So I have -1 to 4, -1 to 4, -3 to +2, -4 to +1. It looks like I'm adding 5 when I move up 5 units. Let's see, this one says 3 up. So do we add 3 each time to the y? Let's see, 2 to 5. Yes, I added 3. 1 to 4. 0 to 3. -2 to 1. I'm adding 3 each time. Okay, and these two are going down. So instead of adding to the y coordinate, the down will probably be subtracting, but let's make sure. 7 to 1, yeah, subtracted by 6. 1 to -5, I subtracted by 6. 3 to -3, I subtracted by 6. Let's see, this one's going down 1, so let's see if we get a -1 from one y coordinate to the other. 4 to 3, yes, I subtracted 1. 2 to 1, subtracted 1. -2 to -3, yes, subtracted 1. 1 to 0, yes, I'm subtracting 1. So it appears that the x-coordinates represent the left and right direction, with left being negative and right being positive. So you're subtracting if you move to the left, and you're adding if you move to the right. And up and down, you're adding to the y-coordinate, and when you move down, you're subtracting from the y-coordinate. And yes, this slide is explaining that when you translate to the left or right, you're changing the x-coordinate. And if you're translating up or down, you're changing the y-coordinate, just as we had found. So we found these translation rules. When you translate to the left or right, the x-coordinate changes. If you go left, you're subtracting from the x-coordinate. If you go to the right, you're adding to the x-coordinate. When you translate up or down, you're changing the y-coordinate. If you go down, you're subtracting from the y-coordinate. And if you move up, you're adding to the y-coordinate. So translation rules can be written to describe translations in the coordinate plane. So if we are moving 2 units to the left, we start with the coordinates x, y. And when we move 2 units left, we're going to be taking away 2 from the x-coordinate, and the y-coordinate will remain the same because I'm not moving up or down. And then if we look at this one, if we're moving 5 units to the right, we're starting with xy in this scenario. And if I'm moving 5 units to the right, we're adding 5 to the original x-coordinate to get the new one. And if we're moving 3 units down, we're taking the original y-coordinate and we're subtracting 3 from it so that it does move down in the negative direction. So here are the solutions for writing the rule to match a translation that's given to you. 2 units to the left. That means that the x-coordinate is decreasing by 2 and the y-coordinate stays the same. So the rule goes from x comma y to x minus 2 comma y, because again the x-coordinate is decreasing by or triggering subtraction by 2. And because the y-coordinate stays the same, we don't add or subtract anything from it. We just rewrite y by itself as that coordinate. And if we have 5 units to the right and 3 units down, 5 units to the right means that the x-coordinate is increasing by 5. And the 3 units down tells us that the y-coordinate decreases by 3. So the rule will be from x comma y to x plus 5 comma y minus 3. Increasing by tells us addition. Decreases by tells us subtraction within our rule. So now let's come back to these examples that we had from our coordinate plane translations that we moved. Our first one that we had to do was to move 2 units left and 5 up. So we're taking our x comma y and we are moving 2 left. So that's decreasing our x value by 2. From 3 to 1, we subtracted 2. From 8 to 6, we subtracted 2. From 7 to 5, we subtracted 2. From 2 to 0, we subtracted 2. And then our y values, they didn't stay the same. They went up by 5 or increased by 5. And if I do negative 1 plus 5, I get 4. If I do negative 3 plus 2, negative 3 plus 5, I get 2. If we do negative 4 plus 5, we get 1. So this does work as the rule for this translation. Now let's try the next one. Here we're going to the left 2 and we're going 6 down. So we're starting with x comma y and we're going left 2, so that means subtraction, where the x value decreases by 2. And we're going down 6, so the y value will decrease by 6. Let's actually see if this works. Negative 2 minus 2 gives me negative 4. 7 minus 6 gives me 1. Negative 3 minus 2 gives us negative 5. 1 minus 6 gives us negative 5 for this y-coordinate. Negative 6 minus 2 does indeed give us 8. And 3 minus 6 does give us negative 3. So the rule works. Now let's try to do the rule for this one. We're going to the left 5. So we're starting with x comma y. And left means subtraction of x by 5. And then we're going 3 up. 3 up means we're taking the y-coordinate and we're adding 3 to it. Let's check. 3 minus 5 gives us negative 2. 2 plus 3 does give us 5. 7 minus 5 gives us 2, and 1 plus 3 does give us 4. Seems to be working. 4 minus 5 does give us -1. 0 plus 3 does give us 3. And finally, 2 minus 5 gives us -3, and -2 plus 3 does give us 1. So yes, this rule works for this translation. Now let's do the last one. We have x comma y. 2, we're going to the right 4 units. So that should mean that we're adding 4 to our x coordinates. And then we're going down 1. That means we're taking the y coordinate and we're subtracting 1 from it. We're making it decrease by 1 unit. Let's see if this rule works for all of the vertices in this set. From -5 plus 4 does give me -1. 4 minus 1 does give me 3. So it works for point A. Let's look at point B. So -1 plus 4 does give me 3. And 2 minus 1 does give me 1. So that also works. -4 plus 4 gives me 0. -2 minus 1 gives me -3. -6 plus 4 gives me -2. And 1 minus 1 gives me 0. So yes, this rule works for the translation of right 4 units and down 1 unit. And here are the translation rules that we did discover on the last slide. In this first set, going left 2 means subtraction of x by 2, and going up 5 means you're increasing the y values by 5. Left 2 means x minus 2, and 6 down means y minus 6. 5 left means x minus 5, and 3 up means y plus 3. If we're going to the right 4 units, that means we're taking x and we're adding 4 to it. And if we're going down 1 unit, we're taking our y value and we're subtracting 1 from it. So these solutions are indeed correct.